We'd like to welcome everybody to this morning's structural technical section. On behalf of ASC Dallas and Structures Group, I would like to welcome Mr. David Thompson from Huitt Zollars. He's a vice president with Huitt Zollars, and he's a transportation structural group lead. He will be presenting today on old iron bridge rehabilitation. David has over 15 years of experience with as a project manager as well as a transportation engineer, serving clients on a variety of projects with a focus on repair and rehabilitation of transportation structures. So take it away.
All right, thank you, Saurabh, for the introduction. Everyone can hear me all right in the room? Great. Just want to make sure I'm projecting okay here. So today I'm going to be talking to y'all about the project that we did for the city of Bastrop, working on a historic truss bridge rehabilitation. And I guess before I begin here, I did have kind of curious, wanted to make sure I tailor the presentation accordingly. How many of y'all have actually done any kind of historic truss bridge rehab in the past? Anybody? We have 1, 2, Charlie's raising his hand, 3. The HC Bridge group should be raising their hand here, right? Yeah. Okay, well, that's great. No, that's good to kind of understand the audience as we get into this. So, let's go. Thinking. There we go. All right, so an outline of where we're going here today. Going to give you a little bit of background on the project, where it is, what we were working with, what we were looking at, the city's goals for the project, and then also after that, jump into what we, Huitt Zollars, did for the city of Bastrop. So project location, we're in Dallas, Texas. Bastrop, if you're not familiar with it, it's about 45 minutes southeast of Austin. It's on State Highway 71, which is the route that takes you from Austin down to Houston. The city itself has been seeing quite a bit of growth recently. Part of that is say like Tesla's moving out to the eastern side of Austin. And so they've had quite a bit of population growth in the city there. To further help orient you, there's a Buc-ee's in town. I know a lot of people, that's how they know where they are in the state of Texas, by Buc-ee's. There's a Buc-ee's in Bastrop. The old iron bridge crosses over the Colorado River, which is just adjacent to their downtown, their historic downtown there. The bridge itself, all these photos that I got in here, this is either from our TxDOT Historic Archives or from the National Register of Historic Places application for the bridge. So some great old shots. This one's of the actual truss structure being erected over the Colorado River. That's pretty cool that they actually have photos from back then. It was built in 1922 and 23 by the Kansas City Bridge Company. The price or the cost for the project was $167,000, which is pretty remarkable. And we'll get to, I guess, what the bids came in to rehab the bridge. It's kind of an order of magnitude different now, right? Or 2 orders of magnitude. It was opened in 1923, and the bridge itself, it actually replaced an older bridge that was there. That was a tolled road. It shows up in some of the photos, I want to say here. The route itself is part of the old historic Camino Real, or the old San Antonio Road, which is a link between Houston and Austin. That's kind of more or less the route that State Highway 71 follows today. Oh, here in this photo, you can actually see that old original bridge, that tolled bridge that was there. It's off to the right side of the photo, kind of in the background there. The bridge was operated by the Texas Highway Department, which later obviously became TxDOT, up until 1993. That's when they built a new adjacent kind of conventional pre-stressed concrete girder and steel bridge next door. It'll show up in some of the photos as we scroll through here. This photo is pretty remarkable to me. We are in what is now downtown Bastrop, so we're on the east side of the river, looking kind of back into the west. And the transformation, right? That's not exactly a downtown, that's a farm, right? And then also the amount of water here. So this was a flood that occurred want to say it was in the 1920s, if I remember correctly, late 1920s. But you can see the river is actually up and out of its banks. It's actually out of its secondary banks, and it's actually flooding what is now downtown Bastrop. This was a one-time event. This has not occurred since then, but pretty remarkable shot there. A little bit about the bridge itself. Working west to east, and east is our downtown side. On the western approach, there are 15 concrete T-beams. On the eastern approach, there's 3 of those same concrete T-beams. Each of those spans about 39 feet long, nominal length. Those are supported on conventionally reinforced bent caps and then some pile foundations, some driven pile foundations. The main spans of the bridge are the 3 riveted Parker through trusses. They were made out of structural steel. I know the name is old iron, but there's actually no iron on the bridge itself. That's just kind of the nickname that it picked up over the years. Each of those trusses is 192 feet long, riveted steel, I should highlight that as well. And those sit on concrete piers with casein foundations. Our total bridge length is right around 1,300 feet. There's a shot from the as-builts of the truss bridge itself. All right, continuing on, the bridge was applied to be a registered historic bridge. It became listed on the National Register of Historic Places in 1990. The criteria for that was criterion A. That's like a significance criteria, and really what's written about under that is its significance as part of that Camino Real or Old San Antonio Road. And then criterion C, which was listed for engineering purposes. The NRHP actually does not specifically say what was significant on the engineering standpoint, but it's kind of one of those assumed things that they're talking about the Parker through trusses. And the reason for that is the concrete T-beams, those were actually standard highway department standards going back to like the early 1900s. So like that engineering concept had been around for a long time. So then in 1993, TxDOT completes construction of that adjacent Loop 150 bridge. At that time, the city of Bastrop took ownership of the bridge. They closed it to vehicular traffic, and they opened it as a pedestrian structure. Over time, TxDOT and then the city of Bastrop did do a handful of, I'll say, minor modifications. One of them you can kind of see on the photo here. If you work your way down the left side of the bridge, you can see the railing significantly different. Well, what this actually is they cantilevered off the original structure of pedestrian sidewalk. You can see the original rails, those original concrete rails on the right side, right? And kind of the difference between the two. So they added that cantilevered sidewalk. There's another photo, you can see it a little bit better. And then they actually eventually took that thing back off and they reconstructed the rails to kind of mimic the original. So the bridge is mostly original, not 100% original. And then on the left side of the photo here, you can see that new State Loop 150 bridge is open. That's TxDOT's facility. At this point, the city of Bastrop has taken ownership. The other thing that they did is, oh, there you go. There's a photo with some people walking across the bridge as well. Is they added some ornamental lighting, and that'll come back into play in the presentation when I talk about our THC coordination and what we had to do for the lighting on the bridge. There was a 2014 report, so the city of Bastrop did a great job after taking ownership. They did do fairly routine or regular inspections of the structure. They started to note some deterioration, mostly in the gusset plates, not just in the gusset plates, but mostly in the gusset plates. And then in 2018, they decided that they actually needed to close it even for pedestrians due to safety concerns. They didn't think it could carry the live load from pedestrians. So it's been closed for over 7 years now at this point. So there is a little bit of local significance to the bridge as well. Some of this we learned when we were out on site. Specifically, we learned about the Society of Bridge Spitters, which is exactly what it sounds like. It is a group of locals that go and spit off the bridge. We were told we could fill out a form and spit off the bridge and we get a t-shirt, but we figured we'd wait until maybe the construction's finished and we could do that as like a little celebration or something to that effect. There are these locks on the bridge. It's kind of like their equivalent of the Locks of Love Bridge, if y'all are familiar with that in Paris, the very famous one. Not to that magnitude, right? They don't have to go in there and cut them off every year to reduce the dead load, but people, same idea, they etch their names in the locks and put them on the structure. And then also on the east side, just in downtown, there is the Iron Bridge Ice House. You can see in their branding and their logo, they use the old Iron Bridge. And then they have this beer, the Rivet, which is an India Pale Ale. But all that to say, there is definitely some local importance to the structure as well, which we had to have in mind as we're working through the project. We need to understand how important it is to the city of Bastrop and the people that live there. So that's the background on the bridge itself. Now a little bit for the project goals. So before we were brought on, the city of Bastrop, specifically their Parks and Rec, put out this master plan where they talked about how they wanted to rehabilitate the bridge and reopen it. These renderings that I have on the screen here, this is all from that master plan that they put together. Great architectural renderings, some that from a structural engineer, obviously not a huge fan of, like putting a tree on a bridge, right? And I'm like, okay, maybe we'll cut that. But thankfully, we'll get to that. That did get cut. So big picture, though, their main priority was, let's get this thing reopened. Then from there, it's what can we achieve from the Parks Master Plan? What is reasonable? What will the THC accept, right? And in regards to what will the THC accept, that was really critical as well from a schedule standpoint. So the Texas Historic Commission, because it is NRHP listed, they do have a say in what can be done. They can't tell you no, but they can tell you that you are adversely affecting the historical significance of the bridge. And if you negatively impact the historical significance of the bridge, then you have to do some offset mitigation that's associated with that. Maybe some of y'all have worked on like a 4F on some of your other projects. It's basically that process. City of Bastrop stressed to us they wanted to get us under contract and then have the project let within like 15 months. And so we took that in mind and we said, okay, well, to achieve that, we're going to have to do what the THC wants us to do so we can get a no effect. So that's like a no impact determination. Because that mitigation process, the going back and forth, the coordinating on what those historic offsets would be, that's a lengthy process. That's years in the making. So that kind of set the framework for what we felt like we could achieve and maybe what we couldn't achieve. There's some more renderings from the Parks Master Plan. So understanding the deterioration of the structure and then also the historic significance of it, we kind of put together our project team. So Huitt Zollars, we're the prime engineering consultant for the project. With that, we handled the condition assessment, the load rating, all the design side. We did some survey on the project as well. We brought in our partner ICF, formerly Blanton and Associates. They're very key on, I'll say, these historic truss bridges. Mary Ellen Russo has a long history working for TxDOT on historic trusses and really is kind of the go-to person in the state for that. So they were brought in to work through our core permitting and then our THC coordination, our cultural resources report. Lone Star Environmental Services did our paint sampling. There is lead paint on the bridge. They also wrote the specifications for like containment requirements and then abatement of that lead paint. Under bridge platforms, that was a guy out of Broken Bow, Oklahoma. He just basically brought us the equipment we needed for the condition assessment. And then Wolpert did an underwater survey of the foundations down in the river. That sets the stage. So in March of 2024, our team went out there in the field and did a condition assessment. The equipment that we used was an Aspen 30 underbridge platform. That's what's shown on the photo here. That thing can basically telescope out and then swing back under the bridge. We used that to look at the bottom side of the concrete T-beam approach spans and then also the underside of the truss as well. So like the floor beams and stringers and lower gusset plates, that kind of thing. For all the overhead portion of the bridge, we used an articulating boom lift, a man lift, if you want to call it that, to get everything above us. So the sway bracing, the top cord, all that fun kind of stuff. Really the keys to any condition assessment is to study in advance. So review your as-built plans, right? Also review any kind of previous inspection reports so you have an idea and an expectation of what you're getting yourself into when you get out there in the field. And then the other part of this is really having a plan. And what I mean by that is not just like a plan of what you're going to do day to day and a safety plan to make sure you know what to do if something goes wrong, but also really have a plan of where you think the plan set is going. We knew that we weren't just doing a condition assessment for the city of Bastrop. We knew that we then had to come back to the office and prepare a set of PS&E plans. And so that had to be the mindset going into the field work. We had to know what we needed to document, how we needed to document it in order to then put that set of plans together. And then draw what you know. I showed a screenshot of like the T-beams and the truss, and really it was very minimal. We didn't have a whole lot of information. But we took a guess, we took a stab. We drew up all of the different nodes of the gusset plates with what we kind of knew geometry-wise. So that way in the field, we could go out there and we could document, okay, no, the plate sizes are actually this, and the spacing between rivets is 2.5 inches, and there's this much clear cover, that kind of thing. So that we had something to work with, kind of a starting point, instead of just going out there blind, right? And then in planning, you know, some of our team, we were familiar with truss structures. I had the opportunity to work on some in the past, but you know, it's knowing your nomenclature as well. This photo, I guess it's not showing up on the screen terribly well, but basically defines all the different components, right? Because you want your people in the field to make sure they're talking the same language, they're able to communicate, and they're documenting things correctly as well. I will say a lesson learned on this one is I made a gaffe, and I had a thought when we went out there that the bridge was stationed from west to east, so from the non-downtown side to the downtown side. And we were maybe halfway through the first day, and one of our EITs was like, "Hey, David, I think it's actually stationed the other way around." So I goofed, and we had to flip our notes and correct that and that kind of thing. But that comes with the working in advance. So what did we see in the field? So I'm going to start with the concrete approaches and the typical deterioration, minor spalls, some intermediate spalls, and some major spalls. And the definition for these is out of that TxDOT concrete repair manual, if y'all are familiar with that. And it's just related to the depth of the spalling and how much the reinforcement is exposed and that kind of thing. There was also an overlay on the approach spans. This was on the truss spans as well. There was some deterioration of that overlay. And then obviously, or not obviously, but I'll say the joints were essentially filled when they did this overlay as well. On the truss structure itself, there's quite a bit of pack rust. Here we are looking at a photo of where one of these stringers, the longitudinal stringers, frames into a transverse floor beam. And this little angle that's sitting here that the stringer is sitting on, you can notice it's bolted through, or riveted, excuse me, through the floor beam, but then the stringer itself actually just sits on top of it. Well, we did some work back when we were in the office, and we demonstrated that this really was probably a fabrication little connection there. It was just seated while they could rivet the rest of the thing in place. And so our repair for this condition is just to simply take those angles out. Let's get rid of that pack rust by taking that little seat out of there. What else do we see? There was some full section loss. So there used to be an angle here. Now you can just see a jagged edge, right? There's not much left there. There was a little bit of impact damage. This is the incline end post. The bottom, it was a back-to-back channel section. These are the flanges, the bottom flanges. You can see they're kind of warped here. They got hit over the years, right? There's a shot of one of the portal bracing, drew a line in there, a straight line in there, just for frame of reference of like how much it's been warped and deformed out of place from impact. And then really the one that raised the most red flags, I'll say, was the deterioration in the gusset plates. And those gusset plates are where everything frames together, right? These are lower gusset plates. This is the bottom cord running left to right on the screen. There's your diagonal and then your vertical posts. It all comes together and is connected at these gusset plates. You maybe can't see it in the photo, but those two little rust circles that are on there, you could actually put your hand through. There was no steel remaining. And so that's part of, you know, why the structure was closed, right? There's a shot in between the two gusset plates. And what's interesting on this one is if you look closely enough, there's like a green little square in the middle of the screen. Well, that's because you can see down and to the ground below. Well, there was at one point in time a batten plate there. It had just completely deteriorated and it wasn't there anymore. But that's not to say that the structure is in terrible condition by any means. I threw this shot in there to show you one of the upper gusset plates to show you how parts of the structure and parts of the bridge were still in pretty good shape. There is a little bit of, paint system failure. You can see the paint flaking off and that kind of thing. And then also there was a little bit of this throughout the structure, kind of some history or evidence that it had been repaired over time. There was no documentation of what kind of repairs had happened. But if you look at this diagonal kind of come in bottom left of the photo up to the top mid, look at those, it's actually bolts, right? You can see the washers and the nut and the bolt threads on the bolt. So those weren't original. That was replaced at some time. It wasn't re-riveted. Instead, they just used conventional bolting. All right. So I'm going to jump into the Texas Historic Commission coordination. So, or THC, I'm going to say THC hopefully from now on because that's a mouthful. So this is required by Section 106 of the National Historic Preservation Act. It's also required by the Antiquities Code of Texas. There's a specific chapter and that escapes me. But the THC's purpose is basically to make sure if you're doing a project on a historic site, in this case a bridge, it's that you preserve the historic integrity of the structure. There's a lot of, the way the code is written is kind of open to interpretation and what that can mean, right? And so project to project, depending on who your reviewer is, you may get some different feedback in that sense. But to start our THC coordination, we actually invited them out onto the bridge on the last day of our condition assessment inspection. We did that to really show them firsthand what we were seeing. So why were we going to propose, as an example, replacing the deck? Or why do we feel like we needed to repair the floor beams? Or why was there need for spalling repairs on the concrete approaches, that kind of thing. So photoed here is a couple of members of the THC and then also a member of the U.S. Army Corps of Engineers that was going to be the one providing oversight for the project. And they jumped right in. So I think this next photo I have here, so our THC contact, Miranda, she said, hey, take me in your cool little underbridge platform and let's go check it out. So she hopped in, put on some safety gear and went down under and looked at it. So at the same time, the other thing that we did is we shared with them, the city of Bastrop's, that master plan, those renderings that I had in those first couple of slides, just to get some general feedback. And it's kind of interesting. They don't directly tell you no. They're maybe kinder than that. Sometimes you wish they were direct, though, at the same time. But they'll say, I'm not sure if that's something that we would be interested in, that type of thing. So the big picture kind of overarching thing that they shared with us is we want to make sure whatever you do reflects what the original intent of the bridge was. Well, it was originally a vehicular bridge, right? So some of the things they weren't a huge fan of were the trees on the structure. They said a vehicular bridge wouldn't have a tree growing in the middle of it. So, and us as structural engineers, we were A-okay with that. 99% of the deterioration we saw on this bridge was caused by water. So we weren't really a huge fan of the idea of bringing some type of irrigation out on the bridge and then watering plants, right? So we said, that's great. Yeah, we'll cut the trees. That's okay. The other thing was some of the, I'll say, and do I have that photo here? Is that what's next? Yeah. Was some of the, I'll say, architectural features of what we were planning to do. So shown in the top left is like the pavement patterning that we were planning to put on the deck after it went back in place. And so there's like stained and colored concrete and different stamps and different form liners and that kind of thing. And they said, a vehicular bridge really wouldn't have this. So we're not sure that we're a huge fan of all the bright and vibrant colors. Again, as structural engineers, we said, great, that sounds fantastic. Let's just make it concrete, perfect. But we did share with them some of our initial architectural concepts that our landscape architects put together to get that first feedback. And that kind of set the direction for where we knew we were headed. I'll say from a structural rehabilitation standpoint, they said, do whatever you need to do. Do whatever you need to do to fix the bridge, to reopen it. That's our goal. We want to see people using it as much as the city of Bastrop does. So we weren't really restricted in that sense. All right, on to the load rating. This is a busy slide with a lot of text. I apologize, y'all. Y'all can ask me questions later if you have any. But what did we load rate? We load rated the T-beam approach spans and then all the components of the truss. And what did we rate it for? An H10 vehicle, pedestrian live load in both inventory and operating ratings. And that's really because that's going to be the purpose of the structure when it's reopened. So the H10, that's the maintenance vehicle that's required by AASHTO for pedestrian facilities, and then the pedestrian live load as well, obviously. So our design specification, it's the manual for bridge evaluation, and then we use a whole mess of supporting things outside of that, like AASHTO LRFD, the original, or not the original, but AASHTO standard specifications. And then there's a mess of research that the federal highways have done over the years, and even the state of Texas, on how to properly load rate truss structures, how to properly load rate gusset plates as well. So quite a bit of background. On the screen there is an example of, you know, some of the work that we had to do. Most of the members of the truss were some type of built up member. They weren't just rolled shapes, right? So you couldn't go get the structural properties out of an old catalog. So we had to do some math. That's the fun part. Well, it was also built in 1923, but thankfully in our library at Huitt Zollars, we had an old pocketbook from that era that we were able to use, find the appropriate shapes, calculate all those section properties. So for the T-beams themselves, we utilize TxDOT's rate spreadsheet, which is a pretty straightforward little spreadsheet. It's great. For the truss, we did I'll say a global finite element model. The overall rating factor, if y'all are familiar with doing load ratings, that equation hopefully looks familiar. The two, I'll say, kind of nuanced things that are in there is one, the bridge condition factor, and then the bridge system factor. So AASHTO MBE tells you for riveted structures, you should apply this 0.9 factor, that's just blanket. And then depending on the MBI rating of the different components, you kind of have to penalize yourself additionally. So the gusset plates, as an example, they had to have a 0.85 factor. The floor beams had to have a 0.95. And then also in the MBE, they do tell you that you should really only account for the remaining portion of the section. So if you had deterioration where you, say, have a hole in your gusset plate, right, you actually have to account for that in your analysis. And so that's done through those condition factors that we're talking about. Whoops, I don't want to skip ahead. But then also we went ahead and did some breakout models, some finite element models of the gusset plates themselves to look at what the behavior was with these holes in them based on our field notes. We did not do any steel sampling to verify, say, like the yield strength of the steel. So instead, we just utilized what the MBE tells you based on the era of the structure. All right. And then here I do have a note that we calibrated that finite element model against the as-builts. And that's based off of this little note in the plans that may be hard to read. But basically, they said, hey, we're going to assume it's 3,200 pounds per linear feet for dead load, and live loads about 1,200 pounds per linear feet. And then in their elevation view of the truss, you know, method of joints, method of sections, whatever they used back in the day, they calculated those dead load, axial forces, tension, compression, whatever it was, gave them on the sheet, and we kind of used that to backtrack and make sure that our modeling assumptions were appropriate for that global model, right? What's pretty interesting or important to think about in that respect, that live load, that 1,200 pounds per linear feet of live load, that's what the bridge was originally designed for. When you calc out what 90 PSF of pedestrian live load is, right? That's the future purpose of the bridge. That comes out to about 1,700 pounds per linear foot. So our goal is to actually increase the live load on the structure, is basically what that told us, right? So we kind of knew that going into it to know, okay, are we going to be in trouble and not actually able to achieve the city's goals? There's some screenshots of some of those breakout models that I was talking about of the gusset plates. So results of that load rating, and maybe I mentioned this, maybe not, but to backtrack, we rated the structure for its deteriorated condition, so the existing condition, and then what we called the original condition. So that's say if the bridge just opened today and there's no rusting, no section loss, that kind of thing. And the reason we wanted to do that was to understand, okay, if we reopen this as a pedestrian facility, are we overstressing certain components of the bridge? Do we need to do some type of structural strengthening in addition to just overall rehabilitation, just fixing the problems that are out there? So the answers that we got out of that was for the existing condition, we had about an H4, so we didn't quite get to that H10. Our P was about 10, that's very low. That's on the floor beams specifically, and really that is driven by the fact that some of these floor beams out there, the top flange was gone. I didn't include a photo of that, but yeah, it was just essentially the deck was on a knife edge of the web is what was going on. Then for the original conditions, so like let's say everything was perfect, you can see we meet the requirements of the H vehicle. We're at an H21, that's greater than H10, that's good. But for pedestrian, we're at P78, and our goal is P90, or 90 pounds per square feet. So what that told us is, yes, we do need some type of strengthening in addition to rehabilitating the bridge. It was localized just to the gusset plates, and it was actually localized or specific just to the shear strength that we could get out of the rivets per the code again. So for those specific nodes or locations, our plans include just removing and replacing the rivets with high strength bolts. All right, on into plans. So PS&E development. So what all did we include in the plans? I got a list for y'all here. For the approach spans, we did some work on the riprap. We did concrete repairs. That's related to all the spalling, the minors, the majors, the intermediates. We're replacing the joints. We're actually taking off that asphalt overlay and replacing it with a new, I think it's a latex modified concrete overlay, if I recall correctly. We did have to modify the rails. This was one of the items that we had to coordinate with the THC. There's a term called character defining features. In their mind, the existing rails, even though I showed you all the photo how one of them was removed and replaced to build that sidewalk, they said the original rails are part of the character defining features. You guys cannot replace those. So we had to come up with a concept to meet current rail opening requirements, if y'all are familiar with that. So basically, we're stringing wire in the openings to meet those requirements. This was just like a little SketchUp that we put together to illustrate for the THC what we meant by that proposed plan. And then a waterline brace hanger replacement. This is kind of ancillary. This is not really related to the structural condition of the bridge. But there's a ductile iron pipe that was hung off one of the sides, and it was literally hung at certain locations. There was just a cable wire that was wrapped around the rail posts and then wrapped around the pipe. So we went ahead and actually put together a true anchorage for that. All right, there's some shots. All right, now for the truss spans. So we did include in the plans cleaning and painting the entire truss. That included the requirements or in the specifications were all the requirements for containment and abatement. In the plans, we just really provided them with like a square foot of steel quantity and then what the paint system was, what the color was, that type of thing. We are replacing the deck, the full deck on the bridge, and that is critical, I'll say, for the rest of the work that we're doing on the truss. So we really needed to take the deck off, one, to repair the floor beam top flanges, right? If you can't get to the floor beam top flange, you can't necessarily repair the top flange, right? And then also we needed to take the deck off to kind of relieve some of that load. We needed to reduce the amount of dead load on the structure so we could do some of our other kind of critical repairs like replacing the gusset plates. We didn't want to take a gusset plate off with a whole bunch of dead load on the bridge. So that kind of jumps ahead to what some of the other repairs are, which is it does include gusset plate replacement. We're doing some heat straightening of those impacted members. We're replacing the portal bracing at certain locations. That's where I showed you all that it had been hit, at some point in time in its history. And then a new pedestrian rail, some new lighting, and some other miscellaneous repairs. Kind of going back to THC coordination, and this is where it gets really interesting because you're working with a person that has a very open to interpretation way to apply their code, right? And they said take the trees off the bridge, take the colors off the bridge. But when it came to lighting, there was some old antique lights out there, and we had originally proposed to basically put additional lights, so that same nature out there to mimic what's there, but to meet current requirements for illumination for a pedestrian facility. And the THC said no. They said, nope, we don't like that. It's not part of the original bridge. If you're going to do some lighting, we'd like it to be modern, which this is the light fixture that they approved. You can see is definitely very modern, right? So it's one of those things that you just say, okay, and you move on, but you kind of scratch your head. You're like, okay, how did we land there from an old historic bridge to whatever this is? So, and then on the left side of the screen, that photo that's up there right now, that's just a rendering that we put together for them showing what the new pedestrian railing would look like in front of the original. They wanted to make sure that we didn't take the original truss railing off. That's the 2 channels that just run longitudinally along the bridge. So we put together a little SketchUp kind of demonstrating that. So what else did we do during PS&E development? We did consult with Bridge Division. It's a pretty significant structural rehabilitation. We wanted to share with them what our plans look like, how we were approaching it, that type of thing, to get some insight and feedback from people that maybe do this a little bit more often than anyone else. And at that same time, also, we reached out to a truss rehabilitation contractor to kind of walk them through what we included in the plans, how we presented it, what the requirements were, that type of thing. And definitely got some good feedback from both of them. What I have shown on the screen here is the concept for replacing one of the gusset plates. We did require that the contractor prepare an erection sequence plan that's signed and sealed by an engineer in the state of Texas. But at the same time, us as the engineer of record, we did work through all of the analysis to ensure that what we were putting in the plans is structurally feasible, right? We didn't want to tell them that they could take a gusset plate off if it actually overstressed some member in the bridge, right? So we did work through a sequence of work to basically to vet it. On the bid side of things, we did require that bidders provide previous example projects. That's in addition to like references to contact. And we did that by bid item. So as an example, and also I should say by the contractor that is going to perform the work. So, your prime maybe does, 60% of the work, but maybe they're going to sub out the painting of the structure. Well, we said, hey, whoever your painting sub is, they need to submit their qualifications because that's really who we want to check and vet. And we didn't do it for all the bid items. I'm sure plenty of contractors have experience replacing riprap, so we didn't ask for it on that. But for key items like replacing of the gusset plates, for painting of the structure, for some of the floor beam repairs, that type of thing, we did say, hey, you have to demonstrate that you've done this type of work in the past. Otherwise, you are not a qualified bidder. And then also the contractors were required to participate in a mandatory pre-bid meeting that was hosted by the city of Bastrop. We joined as well, walked them through the plans, and then actually went out to the site so they could see firsthand not only what does the access look like, but what is the deterioration. I should say our plans did also include annotated photographs to kind of give the contractor a general idea of what they're getting into before they provide their bids. There's a shot of another shot of a screenshot there. So where are we in the project? So bids were received on April 17th. We had 4 qualified bidders, which is great. The average bid was right around $12.5 million. Our engineer's estimate, I want to say, was right around $15 million. And then the contract was awarded on April 29th to J. Reese Contractors for about a $10 million bid. Construction is set to begin in August, So Jay Reese is currently working through their erection sequence plan and also preparing shop drawings for review and that kind of thing. They think they'll have boots on the ground in August of 25, and then per their schedule, it was a little over a year, so I'm going to say fall of 2026. So closing with this shot of the sign that's on the bridge, currently closing it because the city of Bastrop is very excited to finally take down this fence and take that sign down, and they are getting closer. I believe before I get into questions, just wanted to say thank you to the city of Bastrop for really the opportunity to work on this project. There's a shot of the Huitt Zollars team. This was us enjoying one of those Rivet IPAs after a hard day's work, right? All of our sub-consultants were fantastic on this job, and the THC, they were a great coordinating partner as well. They really were. They communicated well, they were responsive, and they did give us great direction. So really thank you to everyone involved, and also the Sugar Shack, which is a local Bastrop place that kept us going. So with that, I will pause and I guess open it up for any questions that anyone has.
Show the shop where the spalling was occurring, reinforcing steel with exposed. Just measure the coverage. Was it that coverage of the steel be current standards? And if it's been current standard, would you have that spalling for wood?
Yeah, so if I recall correctly, so Tim's question was about the spalling on the T-beams and the coverage that we saw out there. So I want to say the details in the plans is about 1.5 inches of coverage, which does not meet current requirements. No, Tim. And would that have occurred? Probably. I'll say we still see that. So that photo, if I cruise back here, whew, I'm going to say yes, because there's other things going on with the detail that likely are what contributed to it. So in the photo here, you can see the staining of the concrete, right? And then also what's actually going on is this is a deck drain from up on top on the bridge deck. So this is where water was coming off the bridge deck and just working its way down the inside face of the T-beam there. You know, really a better detail on this would be to actually bring it in some type of pipe all the way down to the bottom of the T-beam before it falls, you know, down to the Colorado River below, so that you don't get the water penetration and the chlorides and all that kind of stuff into the concrete. So that's why I say yes, it probably still would have occurred even with proper cover. Those are square rebar, yes, yep. You know, I don't know that they're necessarily more at risk for corrosion, but I will say, you know, it's pretty unique, but it's definitely the age of the structure. That's kind of what we have working with here. I don't believe we got to the point where the spalling was significant or the deterioration of the reinforcement was significant that we had to actually like drill and grout or propose to drill and grout and put in new reinforcement. It was corroded, yes, but from what we could tell, it probably still had the majority of its cross section there, which is good. I'll say that. So, if someone else had a hand up, Mofi? Yeah, so we did. Exactly. So if I cruise ahead here, so we had this full model of the entire bridge, and we used this for rating of really our axial compression and tension members, so like the top chord, the bottom chord, the diagonals, the vertical posts, right? And for that purpose, it's probably accurate enough. Where we had to go in and directly, say, model some of the loss of stiffness, I want to say we did on the floor beams, if I recall correctly, like where that top flange was gone. We calculated the section property directly and used that as our element to account for maybe there's a little bit of distribution of stiffness through the system that's not what was originally intended. But then also on the capacity calculation side of things, We did not treat, so the floor beams, they're kind of like an I-beam shape, but they're made up of a web plate and then 2 bottom flange angles that are riveted on, and then 2 top flange angles that are riveted on. So we kind of just turned that into like a T-beam shape, essentially, when we did our capacity. And then these breakout models that are shown here, these were at localized locations where we did see that significant deterioration, which it ended up being at every node. So every lower gusset plate. So we did end up modeling every lower gusset plate. We did not model it for all 3 trusses. What we did is we said, okay, for node L1, as an example, what is the worst case deterioration wise for all the L1s on all 3 trusses? And then that's what we represented, and then that's what we load rated. So we rated one span for the worst condition is kind of the way to think of it. That's correct. Yep. So we did a couple of different sensitivity analyses to see like what the impact was, that kind of thing. From what I recall correctly, like forces in the rivets maybe didn't change a whole lot. Obviously your stress distribution, the distribution of stress changed, but the magnitude of force didn't necessarily change either. So it's basically, you know, say it's still 10 kips of compressive force, but now it's over a smaller area instead of a wider area. Yeah. Any other questions? Yes, Jody.
People right now, once they start the movie, what I see, something is like what they are building.
Yeah. Yep.
You have a team going to do inspection of what they are building.
So we're scoped to provide construction phase services, and the way that's scoped is a couple things. One, we're just doing general shop drawing review, and we'll review their erection plan. But then we're also scoped to have an on-site engineer, I want to say 1 day a week. And then in the bids themselves, we did have some intentional overruns on things that we knew once they popped the deck off, it was probably going to be in worse shape than what we could visually see in the field. And so we had intentional overruns in those quantities for that reason. And basically the way it'll work is, I think if I remember how the specifications are written up, they'll take the deck off, they'll say, hey, this floor beam wasn't in your plans, we think it's in bad shape. Then our on-site rep looks at it, says, yes, I agree, and we get it in there. Yeah, that 10 million of their bid does include those overruns. You know, fingers crossed that it doesn't continue from there, right? So the city of Bastrop actually originally bonded $20 million to do this job. And that's not to say that we gave them $10 million in savings. I'm not trying to sell anyone on that, because their original vision was definitely much more, right? With like, if you remember from those park master plan renderings, there was like overlooks that they were adding. There was obviously all like the planters and the architectural concrete and that kind of stuff. So I don't want to say that we saved them $10 million. Maybe the THC saved them $10 million is what happened, right? But they're also at the same time, they're pretty happy that now they have additional funds to go do other stuff in the city too. So, yeah, Samir. Yeah. So we did not end up going back with lightweight concrete. You know, through our analysis, really the only thing that was overstressed was those specific nodes and rivets in those nodes. And we felt like that wasn't necessarily a need for the project. And then in regards to like headed studs on the floor beam, I don't believe so, but I'd have to go back and look at the plans. Yep.
Or is it just more of an average, what they
Yeah, I didn't include the picture, but there's a great picture in AASHTO's pedestrian bridge design specifications that gets you an idea of like what 50 pounds per square foot of pedestrian live load looks like, what 100 pounds looks like, what 150 looks like. And it's 90 PSF of pedestrian live load, but then there's a load factor on that as well. And it is significant amount of people in a small space, I guess, to say, Jody. We did have that conversation with the city of Bastrop at the onset as well. We said, hey, what's your vision for the bridge? Like, is this just, it's open for people to walk on? Are you gonna host like 4th of July events out here? Like, what do y'all want? And they said, we wanna load the bridge up with people. So we said, okay, all right. Because AASHTO does give you provisions in there to like reduce that live load if the owner understands what the purpose is. But yeah, they were very clear that they wanted people out there, as many as could fit on the structure. Yeah. All right. Thank you all so much. I appreciate it.